But there's functions all around us. Okay. Probably the ones you've seen the most are, temperature is a function. Okay. Temperature is a function of time. Doesn't the temperature of, think of a bowl of water in a microwave. Doesn't it depend on how long it's been in that microwave? Okay. Think about temperature outside. Doesn't the temperature outside or temperature of the moment in the day depend on what time it is in the day? It's colder now than it will be 4 hours from now when the sun gets out a little bit more, right? So temperature is we call it a function of time. It's dependent on time. Okay. Your height is a function of how old you are. Okay. As you start off, you're pretty small, right? Okay. Start to get older, you start to get taller. Okay. But eventually, then you start to get shorter. Correct. So the longer you live, the older you get, your height fluctuates based on that time. Cost of mailing a package is a function of weight. It's also a function of volume. Okay, but the heavier an object is, isn't that going to make my price go up? Okay, the more volume that I take, I may be able to ship a piece of paper in an envelope. Okay, but if I ship my piece of paper and so it costs me like 50 cents to ship it in an envelope, but if I ship it in a box the size of my desk, so it probably costs a couple $100, right? Taking up space. Now, it doesn't weigh anything, but it's taking up a lot of space. So, cost of mailing is a function of weight and volume. Here are some others that are more maybe aligned with some of the math we've learned in the past. Area of a circle is a function of its radius. Okay, that's the only thing that the area of a circle depends on, right? Pi r squared. The only thing that changes in there is r. The number of bacteria in a culture is a function of time. Okay. Hopefully we know that, right? Science, we put a culture in, or put a swab in some culture, some whatever solution, and it's going to grow as long as we give it time to do so. Okay, and then we can use mathematical rules then to say, okay, if we've watched this culture grow for 24 hours, how many pieces of bacteria are there going to be in there in 48 hours? Can we project to the future? Weight of an astronaut is a function of their elevation. Okay, the closer to sea level, or ultimately the core of the Earth, the heavier you are. Right? Does that make sense? Okay. And the price of a commodity is the function of the demand for that commodity in economics. Okay, talk about supply and demand, stuff like that, right? So it's all function stuff. Skip that. Let's talk about the definition of a function. The definition of a function. Okay, a function is just an algebraic rule. Okay, an algebraic rule that takes one value from a particular set. So maybe we call our set over here A. Okay, and we've got a bunch of elements in A. Okay, I'm just gonna make them as points. So I'm just gonna put like 1, 2, 3, 4, 5. They don't have to be positive numbers. They don't have to be whole numbers. They're basically A is some subset of my real number line. Okay, it could ultimately be my entire number line or any portion of it that I feel like looking at. Okay, but it's going to take any one of those values out of there. Okay, and it's going to apply some rule. Okay, and we call that rule. We call it F generally. Okay, but it doesn't have to be F. It could be H. It could be G. Those are the ones we use quite a bit. If we're talking about like profits and costs, we might use P and C and R for revenue or something like that. Just F in general. And it takes these numbers and it transforms them or pairs them up with another value in a different set B. B being another set of your real numbers. Okay? And we call these numbers in B, we call those f of x. Okay? So in A we had x. We'll take those values, apply a rule to them. That rule is going to alter those values and place them in the set B, okay, which is f of x. Okay, so what happens here? Let's just say f, my rule, let's just make it easy. Let's go x squared plus 1. Okay, so if I start with 1, okay, that's going to pair up in B with the value 2. Does that make sense? Plug 1 in there, square it, Add 1, I get 2. Okay? If I look at the value of 2, okay, the x value of 2, run that through my rule, it's going to get me over here. Okay, 2 squared is 4 plus 1 gives me 5. 3, it's going to give me 10, right? 4, going to give me 17. Does that make sense to everybody? Okay? And what happens here is that each element x in set A is paired with exactly one element called f of x in set B. What that tells us is that every time I plug 2 in here, every time I plug this value of 2, or any number over here in this set A, okay, I'm going to get one result back here. Okay? So every time I plug 2 in, I'm going to get 5. No matter how many times I do it. Does that make sense? Okay? What happens is that there's an issue, and these are things that are not functions. The things that are not functions are when I plug 2 in, but I get 5 back, and maybe another time I plug 2 in, I might get 7 back. Does that make sense? Okay? I don't want that. I want to make sure that we get the same f of x back every single time that we plug 2 in. Okay? Now that does not mean that I cannot plug in maybe a different value just to make things a little bit easier. Let's, instead of using x squared plus 1, let's just use x squared. Okay? So if I plug 1 in, hopefully we all know we get 1. If I plug 2 in, I get 4. Plug 3 in, I get 9, and then 16, right? Okay? But what if I plug negative 2 in? What does that get me to? Gets me to 4, right? But that's okay. I can have 2 x values giving me the same y value, right? But I cannot have one x value going to 2 y values or going to 2 f of x values, okay? And that's what this is saying. Okay? We need exactly one element, f of x, being paired with every single x value, okay? A lot of times we use, and this is where I was talking about the notation stuff we want to be comfortable with. You guys have probably learned, if we look at this, we can write these as ordered pairs. 1, 1. We can go to 4, to negative 4. So I'm taking every x value that came over here and pairing it with its f of x value. We got 4, 16. Okay. The nice thing is for us to realize, and you did this in algebra, you were told, basically whenever we see an f and x, we can change it to a what? Just change it to a y. Okay? So these are ultimately y values, right? That's what we say in Algebra 2 or maybe even Algebra 1. And they are. If we were to graph these things, that's what it's talking about. It's talking about the height on the vertical axis. But what is nice is to leave this as the set of ordered pairs x, f of x. Because when I see that notation, when I see that they're using f of x in a problem, they're telling me it's a function. Does that make sense? And I don't have to do the extra work to determine that on my own, okay? Because things that are functions and things that are not functions will have a lot of varying characteristics. And it'll be nice to know, is this rule a function or not? Well, if they're using that notation, they're already telling you, yes, it is. And then all the criteria or all the characteristics that kind of delineate from that being a function exist then, and we can assume that. Does that make sense? But if they use y, if they just say x comma y, okay, now I've got to think, well, is the rule that they're providing me, that are developing these x's and y's, is that rule a function or not? Okay? Because later on we're going to find out that we'll be interested in what we call inverses. Okay? And the first thing to check is to see if a rule has an inverse, is it a function first? Okay? And if it satisfies that, then we can go look to see if it has inverses. But if it's not a function first, we don't even care and we stop. We don't even go on any further. Okay? So it's going to be important for us to recognize that simple notation, that simple change from y to f of x. And we like to leave it as f of x because it makes more, or it provides more information wrapped up in to us or for us. Kind of the last slide we'll talk about here real quick. The domain and range. Okay. What they're saying here is that these values here that we started with. Okay. Ultimately, these are your independent variables. Okay. The variables that do not. We could choose anything we wanted to. Right. Okay. These are referred to as your domain values. Okay. and they're going to be paired up with basically our dependent variable, this 4, depended on what I started with, right? Okay. This 9 that I got depended on the 3 that I started with, right? Okay. So your dependent variable, or your f of x, is referred to as your range. Okay. Just some vocab words that allow us to talk about things in a little bit easier manner. And instead of saying, hey, these are all the values that you plug into your rule, they just call those domains. So instead of saying that phrase, all the values you plug in, or all the values that you're allowed to plug in, they call those numbers your domain. Does that make sense? And your output values are all the values that you get after you plug something in. Those are called your range. Okay. Something that I've noticed in the past that helps people. Okay, if I've got x and y, okay, graphically, maybe it's x and f of x. Okay, either way. But we will talk about domains and ranges for things that are not functions as well. So this is good to use just a y. Those are alphabetical, right? Okay. Domain and range, those are alphabetical as well, right? I put them alphabetical with one another. It tells me domain is my x values and range is my y values. And I talk about that. Hopefully that's something maybe you already knew. That always helps at least one person every year. Because every time I get on a test or quiz, and I ask you, here's a function, what's the domain? There's always somebody that messes it up. Okay, I always put the range first. Or I ask what the range is, and they actually give me the domain values, right? So, to keep those straight, it's all alphabetical. Okay? There's a lot of things in math. I don't know if it was deliberately done that way, but there's a lot of things that kind of work out that way when we use the alphabet to help us out. Tomorrow we'll pick up here with talking about these domain and range values and determining. We should be able to look at a function and determine right away what is the domain and what is the range without doing any work. And that's what we'll start working with tomorrow. I will post a web assign, but it's not going to be due for a couple days.